Mr. Keat here. I thought in lieu of doing the slide presentation, I'd do a video walkthrough of how to solve this problem, and you guys can let me know which you prefer. Honestly, they both take about the same amount of time to make, so it's no sweat off of my back. Also, I get to feel like a YouTube star when I do this, so bonus points. All right, so let's get started on this question, which I posted on Thursday. This is very similar to one that we did a couple months ago, but I changed it a little bit to increase the complexity of both the method that we're going to be programming and just the overall interaction with the programs. So for this problem, we're going to be dealing with the class called APLine. And the description is right here. An APLine is a line defined by the equation ax plus by plus c equals 0, where a is not equal to 0, b is not equal to 0, and a, b, and c are all integers. Okay, there's a hint right there. Remember that. The slope of an AP line is defined to be the double negative a over b. A point, represented by integers x and y, is on an AP line if the equation of the AP line is satisfied when those x and y values are substituted into the equation. That is, a point represented by x and y is on the line if ax plus by plus c is equal to 0. Examples of two AP line equations are shown in the following table. I don't know how to import tables into this stuff. It's really too small for me to see, but maybe you can zoom in and see it. It doesn't seem to be working, but it doesn't really matter because we have the extra examples down here below. Assume that the following code segment appears in a class other than APLine, the main class. Oh, pointing the wrong way, the main class. The code segment shows an example of using the APLine class to represent the two equations shown in the table. All right, I'll just have to scroll to see this code a little bit. So we're going to create a new APLine object called line1, and we're going to give it the values 5, 4, and negative 17. So these represent the a, b, and c values. So this would be 5x plus 4y minus 17 equals 0. Double slope1 equals line1 dot get slope. So we know that get slope, this tells us a couple things. This tells us that get slope accepts no parameters, and then it returns a double. We know it returns a double because it says so right here. Technically, it could return an int, but probably better off returning a double here. Also, we know it's going to return a double. I think it told us that earlier. Point P equals new point 5, negative 2. Now, we've dealt with the point class before, but just in case you forgot, this is the point class right here. I've included it in the program. We know that a point object has two values, two instance fields, an x and a y. And when you construct it, you give it the x value and the y value. And we know that we can get those values by using getx and getY. All right, back to our code. Boolean on line 1 equals line1 dot is on line p. All right, so this tells us a couple things. This tells us that is on line is going to accept a point as a parameter, a point object, not two ints as might have been described last time, but a point object. And it's going to return a Boolean. So keep that in your mind as we work through. Here's another example. Oh yeah, and it gives you what the output should be. So slope 1 is going to be assigned negative 1.25, and then this is going to be true, yada, yada, yada. And then it's going to create a new line. It's going to get a new slope just to check to see if it's working. And it is going to check to see if point P, which is still the same point because it's the same object, is on line 2. And in this case, it's going to return false. Okay, so let's go into our APLine class and let's go ahead and get started on programming. So a lot of AP questions, I don't know what's going to be on the test. We're going to find out this afternoon actually, and I'll relay that information to you tomorrow. But, well, I guess technically if you're watching this on Friday, then I found out about it last night in my future, but your past, and you're going to be learning about it maybe already. This might just be a pointless rambling because you already know about this stuff. Anyway, feel free to fast forward to about 5 seconds from now as I just think about how pointless this whole thing was just now. Okay, here we go. All right, let's start coding. So the first thing we have to do is our class constructor, our class signature here, public class, APLine. It has to match our file name exactly. Capital A, capital P, capital L. All right. Now, we know that we're going to have a couple of instance fields here for APLine, and that's going to be, they have to be private. Private int A, private int, that is not how you spell private, private int B, and private int C. So if we look back, this basically tells us that we have to do, A, B, and C are our three variables that we're going to have to do. Our constructor, remember our constructor is always public, the name of the class, and then the parameters that we have to accept. Int A, int B, int C. Okay. And we can always double check the sample code here just to make sure that we know what we're doing. So when we create an APLine object, we are accepting 1, 2, 3 integers just like that in that order, and that's going to be the order that we store those in our private variables. Oops. All right. So if we did A equals A, B equals B, and C equals C, this wouldn't cause an error, but it wouldn't accomplish what we're trying to do, which is to set the values of our instance fields up here. When the parameters in the constructor are the same name as the actual instance fields that are intended to store the data, then we have to use the keyword this to differentiate between the instance field version of A and the parameter version of A. So where we see this.A, that's referring to this A. Whereas we see just A by itself, it's referring to this A. The only reason that happens is because we have some identifier confusion here. We have two different variables with the same name. Now, oftentimes it's not legal, but it is legal in the case of a constructor method. Or in methods inside of a class where it sort of overrides the variable, the class variable. So if you don't want to override it, or if you want to access specifically the class variable, then you can use this dot to make sure that you are accessing the class variable. So that's how we would store all of our values. And that's it for our constructor, because that's all it needs to do. We have initialized all of our instance fields. Okay, so the next part, we have to program getSlope. Now we know a couple things about getSlope just from down here, just from looking at the example, also from what it described. We know that it must return a double. So public double getSlope. And we also know that it accepts no parameters. So because it accepts no parameters, our parentheses are going to be completely empty. And because it returns a double, we're just going to go ahead and do that. Return. Oh God, I should have practiced doing this math beforehand. What is it now? It's, it's not too bad. It's just -A divided by B. Now, this is another tricky trick here. If you don't catch this, then you're going to end up with the wrong slope every time. Now, getSlope is supposed to return a double, and A and B are both ints. So if you do int division, if A is less than B, then it's going to return a slope of 0 when it should be returning a slope that's a fraction. Or it's always just going to cut off the decimal. We don't want that to happen. So one thing you can do is you can just pick one of your variables and go ahead and just cast it as a double. As long as one double is involved in this division, it will return a double. If they're both ints, then it's going to return an int. It's just going to lop off the decimal there, which we don't want. Okay, and that's it for getSlope. Okay, and the next one is going to be a little more complicated. So this is our public Boolean is online, and it accepts a point object. So we can tell this from the description, also from the example here. So whenever I'm working through these problems, I'm making sure to constantly check the examples, constantly making sure that the implementation matches the sample code that we see. So because online 1 is a Boolean, this one right here, because online 1 is a Boolean Boolean variable, and we are storing the return value of isOnline, assuming that whoever programmed this did not make a mistake, which we can assume if it's sample code, then we know that isOnline has to return a Boolean. It's really that simple. So public Boolean isOnline point P. All right, it's going to accept a point, and a point object has two instance fields. And if we want to see if our point is on the line, then we have to plug those values into our APLine equation. Now, remember, our equation is AX plus BY plus C equals 0. All right, so I'm actually just going to write that out, and we're going to go ahead and start replacing these values with things that we know. So A, B, and C are perfectly fine. They represent the variables that they represent the actual values of A, B, and C in our class. So we can actually leave them like this. But what do we mean by X? Well, we mean the X value of point P. How do we get the X value of point P? We can't just say P.X. Why can't we just say P.X? Because that variable is private. And when you have a private variable, you need to use the public getter method to actually access it. So instead of P.X, we're going to use P.getX. And remember to include the parentheses because that is a method after all. Ooh, I'm hungry. All right, P.P is the name of our point object here, and P.getX.getX is the method that returns the value of x. We're going to do the same thing over here. B times P.getY, just like that. All right, and then C is in itself. Okay, equals 0. That's the question, isn't it? Does it equal 0? If we do this math, will it equal 0? So when it's in question form, we're going to go ahead and turn this into a Boolean. Equals 0. All right, so we're going to do that. And then whatever that evaluates to, either it does, either these three things all add up to 0, in which case this is going to return true, or they don't, in which case it's going to return false. So what I'm going to do is I'm going to go ahead and just create a Boolean object, Boolean answer equals, and then that's going to store it there, and then I'm going to return answer. Now, that's the easiest way to do it conceptually. You can also use our Boolean Zen. Remember, if answer just represents this as a Boolean, then there's really nothing from stopping us from just returning that value, and that would give the same exact result. All right, let's go ahead and run it and see what happens. See if I made a mistake. Is that what it's supposed to output? Let's find out. Let's run the test. I wrote this problem. I should know. Hey, we did it. All right. So there we go. Just a quick recap. When you create the APLine class, you're going to do it with 3 private instance fields. You're going to create the constructor whose sole purpose is to give the values to our private instance fields. Our getSlope method is going to return -a/b and make sure that you cast one of those variables as a double, otherwise it will give you the wrong slope. And finally, our final method is called isOnline. It's going to return a Boolean, so make sure you have that in there, and also make sure you're returning a Boolean. It's going to accept a point as a parameter, and then we're going to get the x and get the y from that point. And send it back. Now, just to clear up any potential misconception here, now we used point P as the name of our parameter, and in our sample code we happen to name our point P down here, but that doesn't actually matter. We can name that point anything. So if we wanted to name that point J, why not? And then we sent J as our parameter. That'll work fine. That'll work just the same. Because the name of the parameter doesn't need to match the name of the argument, as we call it. Remember, the argument are the actual values that we're sending. The formal parameters, what we see in the method signature, just tells us the data type that we need to expect. Now, once J gets sent to isOnline, well, now J is called P, right? Because when we send the argument, it gets a new name when it arrives at the parameter. When it gets a new name when it arrives at the method. If you take a soda and you send it to your friend in Boston, you put a soda in the box, but when your friend in Boston gets that soda, he's going to take it out and say, "Oh, they sent me a tonic. They sent me a tonic. Now I got to go park the car and drink my tonic," right? So even though it's the same object, it has a different name upon arrival into the method. I really hope that you guys watched the video this long just to get that. I'm so embarrassed myself. All right, that's all. Let me know if you have any questions. You guys can reach out to me directly via email, or you can just put comments on this video. All right, that's all. Have a good one. Bye-bye.